we want to prove this theorem, the angle between two vectors x and y can be computed by, we want to prove this formula, and then we will use the law of cosine, which say that if we have a triangle x with three edges, x, y, and z, and the angle between x and y is theta, then z square equal to x square plus y square minus 2 times x times y times cosine of theta. We will prove this equality, the law of cosine at the end. So now suppose we know this, say this lemma. We will use this lemma to prove the angle between two vectors. How do we do so? We want to prove this one. And then we have y minus x square, right? We just use exactly here for z equal to vector y minus vector x. Z is the length of vector y minus vector x equal to the length of vector x square length of vector y square minus 2 times length of vector x times length of vector y times cosine of theta. Okay, we got with the law of cosine, and therefore, okay, so the left hand side is the vectors y minus vector x dot product with vector y minus vector x. That's given by the length or the norm of vector. Some vectors say z square equal to z square is z dot product with z, where z here is vector y minus vector x. Okay, and which give us vector y dot y minus y dot x minus the dot product of x dot y and plus x dot x. And what is this? This gives us the norm of vector y square z2y equal, right, just two scalars, that's scalars product, 2 times vector x times y plus norm of x square. Okay, now we replace the left hand side by this one, replace it here. Then we have, this is left hand side equal to the right hand side. This is what we have, which give us, this is equivalent to, okay, norm x square, norm x square, norm of y square, norm of y square, nothing, 2, in fact, minus 2, minus 2. Okay, what exactly we have is x minus 2, we can throw away, so vector x dot product with vector y equal to norm of x times norms of y times cosine of theta, right? We can just throw this on away, minus 2, minus 2, minus 2. Okay, we can divide both sides by minus 2 after we subtract both sides by this, and then divide both sides by minus 2. Therefore, we have this formula. We are almost done here. We have, so the two vectors say x, I should say somewhere that x is not vector 0 and y is also non-zero. There are two non-zero vectors. They are two non-zero vectors. In particular, okay, what does that mean? That means the length is non-zero, right? Therefore, we can divide both sides by the two non-zero number, which gives us cosine of theta is x dot y over norm of x times norm of y. This we need to prove the cosine, the law of cosine. We can skip it if this is given to us. Okay, what is how to prove the law of cosine? Let me have the picture here. Okay, we need to prove that z square equal to this. So we have this perpendicular same. So here's y. So let's call this y1, y2, whereas y1 is this length, y2 say this length, and this we say it as 8, which is this length. Okay, and we use Pythagoras theorems. So we have for the first triangle, this triangle, for the yellow triangle we have proved the lemma. Law of cosine. For the yellow triangle, we have that we need to compute. Okay, we compute this first, and then we find the relation between x, y, z, and theta, right? Let's compute cosine of theta. What is it? Is y1 over x, right? Okay, let's compute also sine of theta. What is this then? 8 over x. For both these equality come from the triangle, right? This gives us y1 equal to x cosine of theta, and 8 equal to x sine of theta. Okay, y1 is this, and this gives us what is y2 is y minus y1, right? Which gives us y minus x cosine of theta. Okay, now we have 8, we have y2, we can use Pythagoras theorem again to compute z, right? So now we want to use Pythagoras theorem for this triangle. We have z square equal to s square plus y2 square. Okay, s square we know that's equal to x sine of theta. So x square sine of theta square. y2 is y minus x cosine of theta square. This gives us x square sine of square times y square x square cosine square theta minus 2 times y times x cosine of theta. Okay, what is this? So we have x square here, right? Inside we have, so x square sine of theta square, x square cosine of theta square, which give us this. and then y square, and then 2 times x times y times, we do commutative here, so they are all just real number. And because cosine square plus cosine square of theta, this is 1. This gives us x square, y square, 2 times x times y times cosine of theta, which is this form of x square equal to this. X squared, which is exactly the same, which is the formula, the law of cosine we need to put. Okay, so we are done. So here's a way to prove the whole theorem, how to compute the angle between two vectors, which is this one. Usually we can skip law of cosine if we all know what it is.